In lesson 3, we're kind of reviewing or expanding on some of the lessons from grade 8, unit 7 on exponents. So that's something that you might want to go back and look at and review. So let's take a look at what we have here. We have Math Talk, exponent rules. Rewrite each expression as a power of 2. All right, so one of the rules that we need to remember is basically what to do when we are multiplying exponents. So I'm going to write this out the long way first. Okay, so we have 2 to the third, which is 2 times 2 times 2. Okay, I'm going to bracket that out. And then we have our second one, which is 2 times 2 times 2 times 2. All right. So now what we're going to do is we're going to add up how many times 2 shows up. So we have 1, 2, 3, 4, 5, 6, 7. Okay, so this is 2 to the 7th. Okay, and so what we can see, let's do one more actually first. So this is going to be 2 times 2 times 2 times 2, and then times our 2. Let's count up our 2's. 1, 2, 3, 4, 5, 6. So this is going to be 2 to the 6th. Okay, and so our rule here is basically what you do is you add the exponents when you are multiplying bases. Add exponents when multiplying bases with when multiplying bases. That's all I need to write. Sorry about that, guys. Okay. Now, when we look at the next one, okay, these are division problems. So I'm going to come over here just to give myself a little bit more space. But we have 2 to the 10th. Okay, so let's go ahead and write that. So I have 2 times 2. One, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, and now we're going to divide that. Boy, it's a horrible 2. There we go. By 2 to the 7th. Okay, so now remember, whenever we are dividing, okay, and we have something that is the same, like let's say we have a over a, okay, what that equals is 1. Okay, if I have a smiley face, right, divided by a smiley face, that is equal to 1. Okay, so anything over itself is 1. So if I have 2 over 2, that's 1, so I can cross it off. I can do that for all of these where there's a corresponding 2. Okay, and now I'm left with 2 times 2 times 2. So this is going to equal 2 to the 3rd. All right, and so when we are multiplying, when we're dividing, okay, exponents with the same base, we're going to subtract. Right, so this one is going to be, let's do it again over here real quick. Then we're going to divide all that by 2. I'm going to cross that off, and now we are left with 2 to the 8th. All right, so that is how you're going to do that. All right, let's look at the next problem here. So we're going to complete the table here, and we're going to take advantage of any patterns that we notice. Okay, so we have our x here, and then we have our base of 3. Okay, so whatever our exponent is, we're going to multiply the base by itself that many times. Okay, so let's look at the first one. Here, I'm going to have 3 to the 4th. Okay, that's going to be 3 times 3 times 3 times 3, and that is going to give me 81. Okay, so that's what we have down here. Okay, I do the same thing for the 3rd. Now let's do 3 to the second. That's going to be 3 times 3, which is equal to 9. So let's put that over here. The next one is 3 to the 1, which is just 3. But what about when we have 3 to the 0? Okay, so the convention for that is going to be, we call this 1. Okay, so that is 1. So I wrote down something that was in our 8th grade Unit 7 materials. Okay, so if b is a non-zero number, basically if it's anything other than 0, okay, then b to the 0, okay, equals 1. This is a convention, okay, one that allows the rule b to the x times b to the y to equal b to the x plus y to remain true when x or y is 0. Okay, and then there's an additional convention that states that b to the negative n is equal to 1 divided b to the n for a whole number n. Okay, so let's take a look at why that is needed. So when we look at A here, okay, so we have 9 to the something times 9 to the 7th equals 9 to the 7th. Okay, so think about the rule that we had up here above. If we had, let's say we think that that's going to be 9 to the 1, okay, times 9 to the 7th. Okay, what that's going to equal now is 9 to the 8th. Okay, so it can't be 1. The only thing, okay, that really makes sense in this situation is going to be 9 to the 0, okay, plus 7, because remember we're adding those, is equal to 9 to the 7th. Okay, and so this 9 to the 0 is basically saying we are not including this 9 when we are adding up all of our exponents. Okay, so if we had like 9 times 9 times 9 times 9 times 9, 1, 2, 3, 4, 6, 9. Okay, so here's our 9 to the 7ths. Okay, and if we're multiplying it by another 9, right, well, we can't do that. Okay, because we already have our 9 to the 7ths and our 9 to the 7ths. So basically what we're doing is we're not including this 9 in our equation, in our multiplication. So what we can do is if we multiply 1 by 999, okay, all this 1 here is now not a base. That's the same as 9. All right, so we do not include it in our calculation, and that is why it's going to work out to be 1. Okay, so that's why we have this 1 right there. Okay, the same thing is going to hold true for the problem below. Okay, it has to be 9 to the 12th divided by 9 to the 0, okay, which is really equal to 9 to the 12th divided by 1 is equal to 9 to the 12th. Okay, so this is basically just a convention. It just means that it's something we do all the time for the statement down here, okay, to be true. All right, and for this to be true as well. Okay, all right, and so let's go ahead. I'm going to write down the answer to this and then come back and explain it. So basically, it's the same thing that I talked about with the orange letters down here at the bottom. 5 to the 0 equals 1. Okay, for positive whole numbers, 5 to the a times 5 to the b, okay, this is where we're going to add our exponents, okay, is 5 to the a plus b. Now for this law to hold true, right, with 0 as an exponent, 5 to the 0 needs to be equal to 1. Okay, so again, that's kind of what I discussed up here as well. Okay, so 5 to the 0 is going to be 1, and 2 to the 0 is also going to be 1. Okay, let's take a look at the Are You Ready for More? Okay, so we know, for example, that 2 plus 3 plus 5 is equal to 2 plus 3 plus 5, okay? And 2 times 3 times 5 is equal to 2 times 3 times 5. So the grouping with parentheses does not affect the answer, okay, or the value of the expression, okay? Now, is this true for exponents? That is, are the numbers 2 to the third to the fifth and 2 to the third times 5 equal, okay, or 2/3 to the fifth? Kind of hard to say what that is, but basically, let's take a look, okay? If I have 2 times 3 to the fifth, okay, that's going to give me 2 times 3, 3, 3, 3, 3, okay? And this is going to give me 243. Okay, so this right here is 243. So this is going to give me 2 to the 243rd. Okay, because 3 times 3 times 3 times 3 times 3 is 243. Okay, so that's when we're multiplying that 3 to the fifth, and then we're taking the 2 and raising it to the 243rd. Okay, or we have 2 times 3 times 5, which is equal to 2 to the 15th. Okay, and so just remember, if we have, we're going to have 2 to the third, right, times 2 to the third, times 2 to the third, times 2 to the third, times 2 to the third. This is equal to 2, right, times, I'm sorry, 2 to the 15th. Okay, because remember, when we multiply, we're adding our exponents. Okay, so yeah, this is totally different. And so which would you choose as the meaning of the expression 2 to the 3 to the 5 written without parentheses? And that's going to be 2 to the 243rd. Okay, which is huge. All right, let's look at the next one. 3.3. In a biology lab, 500 bacteria reproduce by splitting. Every hour, on the hour, each bacterium splits into 2 bacteria. Write an expression to show how to find the number of bacteria after each hour listed. So what we have here is, remember, we have our 500 bacteria. They reproduce by splitting. Okay, so they split into 2. So basically, we're going to be doubling every time, okay, every hour. So write an expression is going to be, we could have 500, okay, times 2. So after the first hour, we're going to have 1,000. Then we're going to have, after the second, 500 times 2 times 2. Okay, so it's going to keep doubling. The next one would be 500 times 2 times 2 times 2, right? Or 500 times 2 to the third. Okay, the next one would be 500 times 2 times 2 times 2 times 2 times 2 times 2, which is equal to 500 times 2 to the sixth. Okay, and so what we can do is we can rewrite this equation as 500 times 2 to how many hours we have, and we'll call that t. So that was B. 500 times 2 to the t. It's doubling every t hours. Okay, so use your equation to find n when t is equal to 0. What does this value of n mean in this situation? So let's see, when t is equal to 0, n is equal to 500 times 2 to the 0. Okay, so remember, because I'm just going to write BC, 2 to the 0 is equal to 1, n is equal to 500 times 1, or just 500. Okay, so what does that mean? That means that at 0 hours, okay, or at the start, we have 500 bacteria. Okay, and again, that's right here. Okay, in a different biology lab, the population of single-cell parasites also reproduces hourly, an equation which gives the number of parasites, P, after T hours is P equals 100 times 3 to the T. Explain what the number 100 and 3 mean in this situation. Okay, so we're going to use what we just learned here. And so we have 100, okay, is going to be the number of parasites at the beginning, or at hour 0, okay, and that's because 100 times 3 to the 0 is equal to 100 times 3. Sorry. Ah, sorry about that, guys. Is equal to 100. All right, and so the 3 means that every hour the number of parasites triples. Let's look at the next one. Graphing the microbes. Refer back to your work in the table of the previous task. Use that information and the given coordinate planes to graph the following. Okay, so graph t to the n when t equals these. Okay, and then for b, graph t to the p when t is equal to these. Okay, if you get stuck, you can create a table. You could also maybe try using graphing technology. Okay, so I basically took the information, okay, from above and plotted it on the graphs. So on the graph of n, okay, so that's going to be this one. You can see the n up here. Okay, 500 is the vertical intercept. Okay, or the value of n when t is 0. The 2 is the doubling of the n value every time t increases Okay, so if we come up here and we look at our equation, we have 500 times 2 to the t, okay, and that's what this is basically saying. This is 500 times 2 to the t. Okay, on the graph of p, where can you see each number? All right, so 100 is the vertical intercept, okay, or the value of p when t is 0. The 3 is the tripling of the p-value every time time, oh, sorry, every time t increases by 1. So that one is going to be 100 times 3 to the t. Okay, remember, here's our graph of p, and that comes from question number 2 above. Okay, lesson summary, you know the drill.